In this particular lesson, we will learn about the control valve maintenance issues and what are the problems, what is the general problem faced in control valve and how to overcome these problems and what are the maintenance strategies to follow and what kind of maintenance is required to maintain a control valve. All these things I will share my personal experience and also the best practices that is followed in industry. So the common problem that is being faced, one of the common problem is deadband. Deadband occurs when the controller sends a signal but the valve does not move. For example, suppose you have a control valve and which is suppose you have a control valve like this and it is driven by signal that is coming from the control room, and this is 4 to 20 milliampere signal is coming. So at 4 milliamperes the control valve is supposed to fully closed 0% and 20 milliamperes it's supposed to be 100% open. Now suppose you have sent a signal of 4.1 milliampere and the control valve still does not started to move. So there is a dead band of like 0.1 milliampere present there. You can see that if we plot the if we plot there is a step change is there. If there is a step change in the input of the positioner, then the control valve maybe even with this step change it is starts to move slowly or later stage like this. So there is a dead band is present. So consequence is that controller must signal a even bigger signal. So suppose there is a signal like this and there is no response, it is flat. Okay, now the controller has to increase the signal. Controller has to increase the signal to the next level. Say it is increased to this level and then only it started to move. Then only it started to move. So this up to this, maybe this is say 4.2 milliamps, there is no response, but when it becomes like 5 milliamps the valve started to respond. So this causes the valve to travel too far, which means either opens or closes more than desired, because the valve started from this position, then it has to complete its 100%. So when there is a 20 milliamps signal is there, it opens more. So deadband is mainly caused by several factors like wrong size actuator, loose mechanical linkage, excess friction of the valve body and actuator, and faulty accessories like positioner and valve is also, maybe the positioner is okay, everything is okay, but the calibration is out of calibration, then also this issue may occur. Second problem is hysteresis. Hysteresis refers to the condition in which the same input signal produces different results of upstroke and downstroke, which means like if you given a signal like 4 milliamps, 8 milliamps, 12 milliamps, 16 and 20 milliamps, and say the valve opened like 0% and here it is like 25.2%, then it is 50.2%, say it is 75.1 and it is 100, but when it is reverse this is 100 but say this is 74.8, this is 50.1, this is 24.1. So we can say that if the signal is increased, so control valve responds when the signal is increasing, so the response may be like this, but when the signal is decreasing the response might be like this. So this the increasing and decreasing trend, it is different. So that's why the hysteresis is present here. Suppose you have a control valve that is control valve regulating pressure. When you increase the input signal from 20 to 30%, the pressure goes from 200 psi to 300 psi. But if you then put the signal back down to 20%, the pressure does not return to the starting position. It stops at suppose at 225 psig. So this can wreak havoc on your process variability. This means your process cannot be controlled very accurately if this type of hysteresis is present. This may be the reason, maybe the loose mechanical linkage between the different components of the valve assembly. Normally what happens that if we have a valve and we have a positioner also, so actuator basically senses the or the positioner basically senses the position of the valve through mechanical linkage. If this linkage is loose or it is not as per the original manufacturing time, then what happens that even if the valve may be 20% open, that due to the looseness of the mechanical linkage it is showing like 18%. So there is a problem with this. So this problem can be solved by avoiding mechanical linkage. Nowadays we are using, instead of mechanical linkage, we are using magnetic coupling. So there is nothing to wear and tear in this case. So with magnetic coupling, the hysteresis issue can be widely solved. And the third common problem is obviously Stiction. Stiction is a combination of stick and friction. The term describes a situation in which the valve gets stuck in a particular position. Like with the deadband, the controller must then put out a large signal which causes the valve to overshoot its desired position. Then, however, because of the valve stem is resistant to motion, it gets stuck in the new position. So there may be several underlying causes of the Stiction. Some causes may be sticky valve internals, undersize actuator, tight shut-off, and media viscosity. So this may be some of the reason, and the solution is also with you, because if it is undersized actuator, you may go with a higher size of actuator. And another thing is nonlinearity. Nonlinearity means even if you are increasing the signal in a linear fashion, suppose you are there is a valve and you are increasing the, now this is the input and this is the output, you are increasing the signal in the linear fashion, but the valve output is not linear. It may be like this fashion. So this is the valve output, and this is the input or the output of the controller. So even if we are giving a linear input, the output is non-linear. And the reason is deadband, hysteresis, Stiction. These are the causes that attribute to the non-linearity added to the process condition and the inherent non-linearity of the valve. Now, how to keep the control valve working properly? We through the last 3-4 slide, we have uh, discussed about the various kind of problem, the common problem that is encountered in the control valve while it is in service. But how to get rid of this? How to keep the control valve working all the time? How to keep the uptime more high and high? So what best practices you need to follow? So the biggest consequence of all control valve problem that is being discussed above is the instability in the control loop. This most often takes the form of dead time. The result is during the delay between the controller sending signal and the valve traveling to its desired position, the process variable level will be either too high or too low, resulting to the tripping of the system. So the trick to avoid the dead time and its consequences is to select the right valve for your application. Make sure the valve is installed correctly and follow a plan of regular maintenance and repair. In this section, we will look into each of these steps one by one. So step number one, proper selection of the controller. This is the most important step, and I have tabulated some of the important parameters that need to be taken care of when we are selecting the controller. And there you can see there are lots of number of parameters that we need to take care of when we are selecting the valve. So it is not an easy task at all, and nowadays However, the software has solved our problem widely, but you need to have an idea about the process. Then only you can select a proper control valve. That's why the experience matters. So in the case of the control valve selection, we if we select the control valve correctly for the service, then half of our problem is being solved. Another thing, the for the selection of the control valve, the process inputs has to be accurate. There has been situations where the actual process condition is not reflecting in the process datasheet. So the maximum or minimum condition that is being mentioned in the process description is way far from the actual condition. So in that case, even if you are instrument engineer or valve design engineer, if you done your job, but due to the change in the process condition, your selection may go wrong. So even after you select a valve and that is being used in operation for a while, and if you find there is some problem with it, then you should again revisit your selection criteria, and you can check the what the areas have gone wrong and what condition have been changed, and accordingly you can ask your OEM or control valve manufacturer that the process condition during the design was this, now the condition has been changed, what changes can be done. The trim may be modified, uh, the actuator sizing may be modified, there may be additional cage or cage size may be modified. So this type of things happens, this type of things happens in the industry. So if you are a maintenance engineer or design engineer, or it does not matter, you need to know the selection of the control valve properly, because this is the one of the major task of the instrument engineer. Then after, if the selection is okay, then the next problem comes is proper installation of the control valve, and this part is obviously taken care by the project engineers who install the valve, and they should take care of certain things. Number one, the valve should be inspected before this is being installed. Make sure there has been no damage, because the valve is maybe the manufacturing to somewhere else. It is manufactured in the Germany and it is being installed in the Nigeria, so there is been long transportation. In the transportation there may be many something may be damaged. So or another thing you can do is, before installing, you should check the valve in the, if the setup is available in your workshop, you should check the valve. You should check the valve, whether the valve is operating properly or not. You can check the tightness of the seat and everything. So this will help you in the time of the commissioning. So if you can check the at least some 50-60% of the valve in the workshop, it will require less time during the commissioning. Also, the control valve should be the last installed object in the line. Before the control valve should not be used when the blasting or cleaning of the line is pending. There has been situation where it has been seen that control valve is being installed in the line and blasting is going on, sandblasting is going on, and some cleaning of the pipe is going on. But this is very bad thing, because the sandblasting and cleaning of the cleaning of the lines will may definitely or have the potential to damage the internals of the valve. So always avoid to install the control valve before the cleaning of lines. It also has to be oriented, it has to be oriented in the proper direction. There is an arrow mark is there in the control valve. You should look at the arrow mark and ask your process engineer direction of the flow, and accordingly you install the control valve. Another thing is, ensure the pipe has ample support and to align the valve properly. Another thing is, provide the valve with enough headroom to accommodate normal operation as well as accessible for the maintenance. Third is control valve maintenance. So we have three stages we are basically showing. First, the design stage where the control valve selection has to be proper. Second is a construction or commissioning phase where the valve has to be installed properly. And the third is maintenance stage, so where the control valve has to be maintained properly. So in the control valve maintenance segment, like all other equipments in the plant, the control valve uh, can be maintained into the three strategies. One is like breakdown maintenance, that is whenever the control valve breaks, then we have the breakdown maintenance. Second is we can have a preventive maintenance plan where we can plan to overhaul the valve in every 2 years and 4 years based on their criticality and performance and the service. And another is predictive maintenance. Predictive maintenance is we can have a baseline valve performance, and then we can look at the present performance, and if there is a deviation we can do the overhauling. So in this way we can save lots of money by not doing overhauling by simply the time based overhauling. Instead we see the actual condition of the valve and do the overhauling. And there is another, that is CBM or condition based monitoring. So in the case of the condition based monitoring, there are the positioners are now coming with the diagnostics tool where you can monitor the performance of the valve online, and if something goes wrong you can take action accordingly. So there are various softwares like Fisher has Valve Link and Metso as Valve Manager, and these softwares can be installed in the instrument asset management system like Yokogawa PRM, and there you can get warning of the valve if something goes wrong, if there is a heavy friction in the valve, or the supply pressure is low, or there is some problem with the positioner. All these things uh, can be diagnosed, and you can have online parameter checking. So if you see this, there is some problem, you can take action accordingly. So there are now the three or four maintenance strategies. Number one, breakdown. Number two, preventive. Number three, predictive. And number four is condition based maintenance. Now, when the fourth thing, that is the breakdown, when the control valve is ultimately break down due to some problems, or we are going into the preventive maintenance, or we are condition based maintenance, whatever it is. So there are some critical problems, or there are some common problems that is being encountered for the control valve. So number one is internal leakage or control valve passing. So if you notice a control valve leaking internally, first check the maximum allowable leakage criteria, that is ANSI or FCI 70.2. Not all control valves are designed to be bubble tight. So there I have one lesson where I have discussed about leakage class. Please go through that, and where the everything about the leakage is being detected. So this is a very common problem, and common problem notified by mostly by operation people or process people. They have always this concern that the valve is passing and disturbing their process in the downstream, and to check whether the control valve is really passing or not, you have to send the control valve to the obviously to the workshop, and there should be some arrangement for the leak testing, and where you can check whether the valve is passing according to this standard or not. Another condition based test is also available nowadays. Nowadays, if there is a control valve and in the downstream the acoustic sensors are being installed to check whether the control valve is passing or not. Another problem is external leakage. This is arguably one of the biggest problem on the control valve, and this is a safety and environment concern. Control valve by far most worst offender for the fugitive emission amount. 50 to 60% of the plant's fugitive emissions comes from the valve, and 70% of that amount can be attributed directly to control valves. More often than not, the problem has to do with the valve packing, This causes ranging from the improper maintenance to material incompatibilities. It has been seen that wrong packing has been used. The temperature is far way more than the tolerable limit of the packing. So this is again the design point of view. If the design is correct, this type of situation does not arise. And also there is some cases there is the service is very corrosive service, or service is very severe. So in that case the packing has to be replaced after certain interval. If not replaced within the certain interval, this may cause the external leakage. And the worst cases, there are leakage from the body also, and this is a very severe condition, and that the leakage from the body may be as a result of the wrong selection of the material, or it may be due to the cavitation or flashing issues. Another problem is stickiness. This is one of the common cause of stickiness is over torquing of the valve packing in an attempt to curtail the leakage. So we normally, if there is a gland leakage, we tight the glands of the valve, but in an attempt to curtail the leakage, what happens is the valve friction, the packing friction increases, and sometimes the valve stem does not move. So the best thing to in this case is, or the best maintenance practice is, if you are tightening the gland, always do the stroke checking after tightening the gland, because there may be the situation that you just tighten the gland and taken the valve online and valve does not move at all, leading to a very uneasy situation or the production loss, or even bigger than that. So if you are tightening the gland, always make sure you are doing the stroke checking after that. Another common problem that is being encountered is actuator adjustment and positional calibration. Positioner gets out of calibration in some cases, and that may be due to the loose mechanical linkage issue, or in some cases the positioner also gets damaged, or there is some electronics fault is there. Also in some cases the instrument air that is coming maybe may contain dust or moisture, resulting in the problem with the pneumatic circuit, and that can cause problem. There are also situations where the problems is found with the actuator, and actuator like actuator diaphragm is passing, or actuator diaphragm has been damaged, or the spring is damaged. All these situations arises. So there are lots of discussion can be done about the control valve maintenance and repair. So I have only tabulated some very important and common problems and associated solutions. So if you have some more doubts into it, you please write in the question answer section, or message me, or comment, so that I can upload more videos if you want in this topic. Thank you all.